Okay, today's lesson is nonlinear systems. Everything that we've done up to this point has been x to the first power, y to the first power, z to the first power. If you were talking three dimensions, I said we were talking like a plane. And we're talking about what if I've got a plane going this way in different directions, and where do those three planes cross? Sometimes it'll be at a point, sometimes it'll be at a line, and that's what we found previously. Today we're talking nonlinear systems, something like y equals x squared and y equals 2x minus 3. Maybe your system looks like that, to where you're wanting to know, you've got this parabola and you've got this line, you're wanting to know where those two things cross. The methods are the same. That's the reason I'm saying this is not a hard lesson. You still either do substitution or elimination. 99.9% of the time you're going to do substitution. So here we go, like on this one, if I wanted to solve this equation, y is equal to x squared, y is equal to 2x minus 3. Since you've got it solved for y equals this, put it right there where that y is at. And you would have x squared equals 2x minus 3, solve the quadratic equation. We've done, like I said, we've done that all year. Let me take actually a problem off the computer and try it now. So here's your first system. And what we're going to do is we're going to solve it algebraically. We're going to verify it with a graph. Okay, so here we go. Again, you've got a parabola, simple parabola, it's quadratic, and you have a line y equals x. Substitution or elimination would be near impossible here. So here's what you do. Y equals x. So in the place of y in your other equation, you substitute in x. You can't solve y equals 8x squared minus x has infinite solutions. But if you can eliminate one of the two variables by either substitution or elimination, now you've got something you can solve. So we take out the y, we put in what it's equal to. We now have x equals 8x squared minus x. Again, it's a quadratic equation. Anytime it's quadratic, you try to get a 0 on the other side. So let's move this over. We now have 8x squared minus 2x, and I'm going to put the 0 at the end. To solve quadratics, now notice here that there's no c term. Normally you have an a, a b, and a c. You factor by reverse FOIL, or you can use quadratic formula. Here, these are easier. Factor out a common term. Anytime c is missing, you will have an x in common. So let's pull out a 2 and let's pull out an x. Pull out 2x, you're left with 4x and a minus 1. So you have two things being multiplied to give you 0, so that means one or the other must be 0. So there's your two solutions. Divide by 2, you get x equals 0. Add 1, divide by 4, you get x equals 1/4. Let me again remind you what you're doing. You have a parabola, and you have a line y equals x. That's a line that has a slope of 1 and a y-intercept of 0. More than likely, this thing's going to cross twice. And that's what you're seeing here. At two different x values, it's going to cross. But again, we're looking for the point. We're not looking for the x value where they're crossing. We're looking for the point where they're crossing, so you've got one more step. This line crosses the parabola at 0 comma something and at 1/4 comma something. I want to show you that this point is on both the parabola and the line. You can plug this 0 into either one. I think I'd plug it in here. Same thing here. This 1/4 is on both lines. It doesn't matter which one you plug it in to find the y value, it should work for both. When I plug 0 in for x here, I get y equals 0. So when x is 0, y is 0. When x is 1/4, I get y equals 1/4 as well. So those are the 2 points where they cross. Okay, next problem, you've got y equals absolute value of 5x and y equals x plus 24. Same thing, substitution. Take out, you can do it either way. Y equals this, so down here in the other equation, plug that in. So you now have the absolute value of 5x equals x plus 24. There were two types of equations that I told you be cautious of extraneous values, this being one of them. the absolute value cannot be negative. So any x value that forces this over here to be negative is going to be an extraneous value. Here's how you solve these. If the absolute value of smiley face was equal to 3, we knew that smiley face could be two different things. The absolute value of 3 is 3, and the absolute value of negative 3 was 3. And that's how we solve these. We took that 5x and we set it equal to x plus 24. And we took 5x and we set it equal to the negative of that. And when you do the negative of a binomial, make sure you do the negative of both. Move the x over. It gives you 4x is 24, so x must be 6. Move the x over. That gives you 6x equals negative 24, so x must be negative 4. And again, in my years, usually what I notice, if you have an x on the outside of these, that's when you have extraneous values. I don't think that you will here, though. Let's check it. When you plug in 6, you get 30 equals 30. We're good there. When you plug in negative 4, you get the absolute value of negative 20, which is 20, equals negative 4 plus 24, which is also 20. So we're good with both of these answers. So you have an intersection at 6 comma something and at negative 4 comma something. Since it's on both of these, you can plug it into either one you want. Let's do the absolute value. I think it'll be easier. When you plug in 6, you get the absolute value of 30, which is 30. When you plug in negative 4, you get the absolute value of negative 20, which is 20. You can check it by plugging into the other one. It should work in either one. Again, x squared plus y squared equals 106. That's in your x squared plus y squared equals r squared form. This is a circle that has a center at 0, 0, that has a radius of a little bit over 10. And then you have a line, y equals x plus 4. If you think about the graphs, when you have a circle, I told you that more than likely you will have two answers, but you don't have to. If it cuts through the middle of it, yes, you'll have two answers. If it skims it, there is a possibility if it's tangent to it, you'll only have one answer, or there's a possibility you won't have any answers. That maybe the line's going to miss the circle completely. So there's your scenarios. You won't have three answers, obviously. There's no way for a line to cut through it 3 times. So it's the same method. Solve for either x or y. I would do it down here. Find the one that it's easier to solve for and then plug it into the other one. So we're going to move our x over. We've got y equals x plus 4. And plug that in for y in your other equation. So now you have x squared plus, instead of y squared, it would be x plus 4 squared equals 106. And now all of a sudden you don't have x's and y's, you have only x's. Make sure that you don't commit the cardinal sin of just squaring each one. Make sure you FOIL this out. We get x squared plus 8x plus 16 equals 106. Get your x squareds together, gives you 2x squared plus 8x. Go ahead and move that 106 over and it gives you negative 90 equals 0. I cannot encourage you enough that when you're given excuse me, this type of equation, try to reduce. Somebody's going to try to do bottoms up here because they're going to say, oh, there's a 2 out front, so you're going to move. You don't do that. You have a 2, an 8, and a 90. If you try, if I'm not mistaken, you can try it, but I believe if you try to use bottoms up on this, it will give you the wrong answer because this is reducible. Anytime you have an equation that's reducible, reduce it. Divide everything, including the 0, by 2. Gives you x squared plus 4x minus 45 equals 0. And then that's not a bottoms-up problem. We factor like normal. Adds to give us 4, multiplies to give us 45 would be a positive 9 and a negative 5. So I have answers of negative 9 and 5. So the points where these cross, I'm going to write them over here, would be negative 9, comma, something, and 5, comma, something. Can't encourage you enough either to, when you plug these back in, plug it into the simple one. These points are on both of these. It is on the circle, but at the same time it's on the line, so why not just plug negative 9 in here? Negative 9 plus 4 gives you... negative 9 plus 4 is negative 5. 5 plus 4 gives you 9. That's the 2 points where those cross. Okay, next one, you have a line, and you've not done xy equals negative 63. You've never done that type of equation before. That's going to be a hyperbola. If you wanted to plot that and see what it would look like, you could pick some points, 9, negative 7, negative 7, 9, negative 63 and 1 and 8. You could find some x values and y values, plot it, but it's going to be this type shape, like a hyperbola looking thing. Then you're going to have a line. So more than likely, again, we're going to have 2 points of intersection here. Not too bad. Solve for either x or y, plug it into the other one. We'll solve the first one for x. Move this over. You get y equals negative x minus 2. Plug it in for y. So you get x times negative x minus 2 equals negative 63, which would be negative x squared. I don't like dealing with negative x squared. We'll fix that in a second. Minus 2x equals negative 63. Since I don't like dealing with negative x squared, just move it. Move it to the right side. Gives me x squared plus 2x minus 63 equals 0. Factor. X and x, positive 9, negative 7, gives you x equals negative 9 and x equals positive 7. We plug those two values back in, and simple as that. Negative 9 comma xy equals negative 63 would be 7, and 7 comma negative 9 is the two intersection points for that graph. Okay, here we go. Last problem. Two different ways you can solve this, but it's the same thing. You have y equals on both of them. They've done you a favor, so just plug one into the other, and you get 5 to the x plus 1 equals 25 to the negative x power. Anytime that you're dealing with an equation that I have x's in the exponents, that is a logarithmic type problem. So if you would want to, I know you don't, but if you would want to, you could solve this with logarithms. I'm going to start solving it with logs, and then we're going to realize that that's the worst way, and we're going to solve it a different way. Have log both sides. The exponent we're bringing down front. So we have x plus 1 log 5 equals negative x log 25. Distribute the x log 5 plus log 5 equals negative x log 25. To get x by itself, and this is where I'm going to stop with this, to get x by itself, we're going to move this over to the left, we're going to move this to the right. You would factor out an x and divide by what it's being multiplied by. And then that would be done. Here's the easy way. And I hope, we mentioned this when we dealt with logs, and I hope you recognize that both 5 and 25 are both base 5 numbers. Anytime you have a base that is the same, work it this way. Change them to where they are both 5s. 25 is the same thing as 5 to the second power. So much easier. You now have 5 to the x plus 1 power equals. Anytime you have a power raised to a power, we multiply them. That would be 5 to the negative 2x. There is only one way for 5 to a power to equal 5 to a power. That's like saying that 5 to the x power equals 5 to the third power. The only way for them to be equal is if the powers are equal. X plus 1 is negative 2x. We move the x's to the same side. We move everything else to the other side. Divide by 3. And we get x is negative 1/3. You can go back and plug it back in and check it. Well, actually, you have to plug it back in anyway. Your x value is negative 1/3. Your y value, because you're looking for a point, we do 5 to the negative 1/3 plus 1. This would be good review. Y equals 5 to the negative 1/3 plus 3/3 would be 2/3 power. The top number, we can leave it like that. That's one way to leave your answer. Here's another way to leave your answer. The top number is a power, the bottom number is a radical. This is the third root of 5 to the second power. So there's another way, and that's probably how I would write it. Third root of 25, cube root of 25. If you would like to check it, you could also plug that into the other. Negative 1/3 plugged in here would give you 25 to the positive 1/3 power, which I believe would also be the cube root of 25.